All right, hello everybody. Let's do a short video about calculating limits. So our first function is a piecewise function that has kind of two different lives. Part of its life, it's a parabola. Imagine that parabola looks something like this. And part of its life, it is a line. And so what I'd like you all to do to get the kind of most benefit out of this would be to pause the video and try to graph those two things and then think about what goes where on the graph. And so, do you want the parabola on the right and the line on the left? Or do you want the line on the right and the parabola on top of it? What's going on, right? Think about for what x values we want the line and for what values we want the parabola. So I'm going to show my picture here. Got it drawn in here. So the picture I have is, right, we want the line for values to the right of -2. So I've drawn the line 1 minus 3x. And what I did was really, I drew the whole line. It went like this. It went all the way through. I went like that. And then I erased it. I erased everything to the left of -2. And then I graphed the whole parabola. It went something like this. And I erased the part of it that was to the right of -2. So go ahead and pause the video if you want to try and reproduce this on your own. Probably good suggestion if you struggle with things like this. So very good. So that is our graph. And how did I know what points to fill in? Well, if I wanted to fill in when x equaled 2, I notice that's going to be happening with the parabola. So I'm going to be plugging that in here. If I plugged in -2 into the top equation, I would get g of -2 is -2 squared plus 5, which is 4 plus 5, which is 9. So that's how I got that number 9. And similarly, if I were to figure out what point would be right here on this line, I could plug it into this equation down here. If I plugged in -2, I would get 7. And that's how I knew to put that open circle there, 7. So with this graph, I now have everything I need to talk about limits. So this question is saying I want the limit as x approaches 6. So I would look on my x-axis around 6. I would say, what is the graph doing? Well, I didn't need to draw more. It looks like it's going down. And I could fill in this point. Again, I would use the equation of the line to work out exactly what I got. Great. So I would see then, in this case, I work it out. At 6, I get 1 minus 3 times 6. It's -17. And from the graph, I get this answer. Very good. And so now let's move on to the next question, which is taking the limit at the more interesting point of -2. And so -2, we have two different behaviors. We have a behavior from the left. So from the left, it looks like the limit is approaching 9, or the graph is approaching 9. So the left limit is 9. And from the right, it looks like the graph is approaching 7. So the limit from the right is 7. And since these numbers are different, the limit does not exist because we only say the limit exists if those two numbers would be the same. So this one would be does not exist. So now let's just do a couple more. So I've written in the answer to this one. It's probably should have erased that. So we're going to see how we got that number. And so what I'm going to do is I'm going to look at this denominator here. In fact, I'm just going to factor. So I'm going to rewrite this. Go ahead and pause the video if you want to practice your factoring, because this is, of course, something you'll be having to do when you take quizzes and homework and things like that. But when I factor, I get something like this. Oops, I miscopied it. It's plus 4 minus 12. And so when I factor it, I get plus 6 and x minus 2. And then I factor the bottom this way. And straight away, I notice that my denominator is going to give me 0 whenever x is equal to 2 or -2. And so I'm going to write down very carefully that x cannot equal 0 and x cannot equal 2. And so with that in mind, I'm going to say, okay, well, I'm never going to plug in 2. I'm never going to plug in 0, because I would be dividing by 0. It would be undefined. But if I'm never plugging in those numbers, then I can do some cancellation. I can cancel this factor of x minus 2. And so I do kind of have this equation that says that this expression here is going to be the same as x plus 6 over x, as long as x is not equal to 0 and x is not equal to 2. And then, of course, it would be does not exist if x equals 0 or x equals 2. And so now I think about the limit. Well, I'm doing the limit as x approaches 2. And I say, well, okay, it doesn't matter whether or not I actually can plug into. What matters is plugging in values like 1.99. So I'm thinking I'm plugging in things like 1.99 or 2.001. And when I think about it that way, I, of course, would be using this top rule, because that's not exactly 2. It's not exactly 0. And so when I do that, we could draw a graph, we could plot some points, but I hope you see that this numerator is going to be approaching around 8. Right? This x plus 6 over x is going to be approaching 8 over 2. Because if we're plugging in things really close to 2, the numerator will be really close to 8. The denominator will be really close to 2. And so these values will be really close to 8 over 4. Sorry, 8 over 2, which is equal to 4. And as you do more practice to these, once you get a simplification, once you get it simplified down to something where you're not dividing by 0, then like 99% of the time you're just going to be able to plug in, unless you have left and right limits and things like that to check. And so let's try the same strategy down here. So let's say we wanted to do this. And so at the moment, again, we have this h is not 0. So I can't plug this in. So I need to get more information about what my function is doing. And so let's aim to simplify. And so this is another good one to pause your video and check your algebra and see if it matches mine. I'm going to work through mine quickly. So if I work this through, I get 9 minus 6h plus h squared, 18. I'm going to write an equal sign because everything's equal to what I'm about to write. And then I'm going to cancel the 18s. Oops, I made a mistake with the sign. So I'm going to factor, I'm going to get negative 12h plus 2h squared over h. And now I'm going to do one last simplification. I'm going to factor out an h here over h. Get rid of this extra stuff. And so now what I'm going to do is I'm going to remember that h is not 0. So since h is not 0, I can cancel these factors. If h were 0, this would be nonsense. This wouldn't even make any sense. But since h is not 0, I can cancel those and say that in this case, with this domain restriction, this function is going to be the same as this function here, which of course is just a straight line. It's a straight line that passes negative 12, has an upward sloping line. So maybe it looks something like this. And remember, our restriction is that h is not 0, our variable in this case, so we're going to put an open circle there. And so now I want to try to understand my function, and I understand that my function, this original thing I wanted, is 100% the same. Maybe I should be a little careful. It's 99.999% the same as this straight line. The only difference is that this function is missing that point at 0, because that's not in the domain. And so again, from the graph, I am going to see that this is approaching negative 12 as our h approaches 0 by the graph. And so what will happen in almost all of these problems is that we will have a problem with the domain, and we will have to do some algebra to simplify it. But then once we do that, we'll be left with a nice function, maybe a line, maybe something a little bit more complicated. But because we're not going to be dividing by 0, we'll be able to use common sense and intuition to evaluate the limits. So thanks for watching, and see you soon.